Today we will learn something really nice. This problem is from ISI BStat Entrance 2005. This is subjective problem number 4. And there are a few concepts that we will learn today. First of all, we will learn about angles at important points in a triangle. So by important points, I mean the circumcenter, the incenter, and the orthocenter. So these will be useful in other problems as well. So make sure you learn them carefully. The second thing that we will learn is a very important tool from algebra. It's called arithmetic mean, harmonic mean inequality. So this is a very interesting problem because it combines two different areas of mathematics: geometry and algebra. So grab a piece of paper and let's do this problem together. One word about chinta.com. If you are new to this channel, this video is created at chinta.com. We offer outstanding programs in mathematical Olympiads, ISI CMI entrances. You can check them out in the link in the description. So I'll tell you what the problem is. I'll tell you the problem. But first, let's learn these two things. Let's fulfill these two learning objectives. Let's draw a triangle, PQR, like this, an acute angle triangle, PQR. And suppose we have the circumcenter. So there is a circle passing through the three vertices, and circumcenter is the center of this particular circle. Okay, so let's call that point C. So let's write this. C is the circumcenter. And let's find out angle QCR. Angle QCR. Let's call this alpha. So what is the value of angle QCR? We want to find this out in terms of the angle at the circumference, or angles at the vertices. So that's our goal. Express alpha in terms of angles of the triangle. Okay, so we want to express alpha in terms of angle P, angle Q, angle R. Angle P, angle Q, and angle R. So how do we do it? So this one is really simple. This is the angle at the center. This is the angle at the center, angle QCR. And this is the angle at the circumference. And we know that angle at the center, is twice the angle at the circumference. So this is a very important theorem in geometry. So angle alpha or angle QCR, angle alpha or angle QCR is simply twice the angle P. This angle alpha is twice the angle P, right? So that one is simple. Let's do the next one. The next one, so I'll make some room here. Let's erase this. The next one is the, so in center. So let's do the in center one. So we already did the circumcenter. Now we'll do the in center. So what is the in center? Let me erase this. So the in center, that is I, is the meeting point of the angle bisectors. In center I of a triangle is where the angle bisectors meet. So this angle right here, this angle is Q over 2. This whole angle Q divided by 2, because this is an angle bisector. Similarly, this angle R is divided by Ri. R is divided by Ri into two parts. So this angle right here is R over 2. Therefore, the final angle, the angle at the incenter, or angle QIR, which we call beta, let's call it beta, angle QIR is simply 180 degree minus Q by 2 minus R by 2. So we have done it. We have expressed angle beta in terms of the angles of the triangle. We have done it. But we can do better, actually. So what we can do is we can write this as 90 degree plus 90 degree minus Q by 2 minus R by 2. Now there is a reason why I'm writing it like this. So 90 degree is basically half of these angles. Three angles of the triangle P plus Q plus R adds up to 180 degree. So if you divide it into 2, P by 2, Q by 2, R by 2, that's exactly what 90 degree is. This is 90 degree. So this one turns out to be 90 degree plus P by 2. 90 degree plus P by 2. So why I like this is because earlier we found alpha in terms of P. Now we found beta in terms of P. So one angle of the triangle. That's great, actually. That's even better than expressing these in terms of all three angles of the triangle. So we have alpha equals to 2p, beta equals to 90 degree plus p. Finally, we will have gamma, which is the orthocenter. So let's do that. Let's find out gamma. So what is the orthocenter? Maybe you know this. The orthocenter is the place where the perpendiculars, the heights of the triangle meet. So it's like this, right? So this is orthocenter H. And we want to find out this angle, angle QHR. So let's make some space. Angle QHR, let's call it gamma. We want to find gamma in terms of the angles of the triangle. We would love if we can find it in terms of only one angle. That would be even better. So let's see how we can do that. If we can do that in terms of P, I don't know. We have to check. So the angle right here, so this is 90 degree. This angle is 90 degree. So the angle right here is 90 degree minus R, right? This is 90, so the remaining two angles must be 90. This one is R, so this one must be 90 degree minus R. That's great. Similarly, the angle right here is 90 degree minus Q, right? Again, this angle is 90 degree. These two angles together make 90 then. So this one is Q, this one must be 90 minus Q. Okay, so angle QHR would be 180 degree minus 90 degree minus R minus 90 degree minus Q, or simply Q plus R. Simply Q plus R. So that's kind of nice. This angle is simply angle Q plus angle R. But we know angle Q plus angle R is simply 180 degree minus P. Remember, we wanted to express it in terms of P. So this is 180 degree minus P. That's my gamma. That's my gamma. So gamma is 180 degree minus P. So we have all the three angles, and I must tell you that these are very useful in any problem. Like this, not only this particular problem, any problem. So I'll tell you what the problem actually is. The problem from ISI Entrance wants you to prove, so prove that 1 over alpha plus 1 over beta plus 1 over gamma is greater than 1 over 45. Okay, so how do you show this? How do you show this? Well, here comes the second tool that we would learn today, the arithmetic mean, harmonic mean inequality. So what does it say? Well, it says that if you have three numbers, let's say alpha, beta, gamma, that their arithmetic mean or average, the average is greater than the harmonic mean. And you see, we have this expression here. That's why I actually thought about this. That's why we should think about using this inequality. Because this expression, the one that we are looking for, comes up. In other words, we know that 1 over alpha plus 1 over beta plus 1 over gamma, so I just sort of cross multiply here, is greater than 9 over alpha plus beta plus gamma. So what is alpha plus beta plus gamma? So we can get it from here. We have already calculated it. So this particular inequality is known as arithmetic mean, harmonic mean inequality. And we are using that, and it's only true for non-negative or positive numbers, So let's do this. So this is 1 over alpha plus 1 over beta plus 1 over gamma is greater than or equal to 9 over 2p plus 90 plus p plus 180 minus p, right? So this is in an acute angle triangle. Remember, that's the part of the question actually. All of this is happening in an acute angle triangle. So this is equal to 9 over 270 plus 3p. 270 plus 2p. So this is true, and we know that p is less than 90 because it's an acute angle triangle. So p itself is less than 90 or less than equal to 90 if you want. Now you can replace p by 90 here. You can replace p by 90 here and the inequality will still hold. Is greater than 9 over 270 plus 2 times 90. So I'm just replacing p by 90. Can you tell me in the comment why can I do that? This is one question that I have for the audience. And then you finally get this is equal to 1 over 45. So there you go. That's what you wanted to show. And in the process, we learned two very important things. One is angles at important points in a triangle, and the other one is arithmetic mean and harmonic mean inequality. Okay, so let me know what you think, and I'll see you next time with another problem. Thank you.